In this episode we are going to talk about operating system. So what is an operating system? The operating system is the most important program that runs on a computer. An OS is a program that acts as an intermediary between the user of a computer and computer hardware. OS simplifies and manages the complexity of running application programs efficiently. Every general-purpose computer must have an operating system to run other programs and applications. Operating systems perform basic tasks, such as recognizing input from the keyboard, sending output to the display screen, keeping track of files and directories on the disk, and controlling peripheral devices such as disk drives and printers. What are the goals of an operating system? Simplify the execution of user programs and make solving user problems easier. Use computer hardware efficiently by allowing sharing of hardware and software resources. Make application software portable and versatile. Provide isolation, security, and protection among user programs. Improve overall system reliability through error confinement, fault tolerance, and reconfiguration. How do operating system works? An operating system communicates with the various parts of your computer. It sends information to and from your computer hardware and the desired application or action in order to carry out the tasks you request. The following pieces of equipment are in contact with your operating system: keyboard, monitor, mouse, printer, speaker, disk drive, and so forth. Your OS receives commands from you through some of these devices and then delivers it to the correct places to process your request. Operating systems perform the following tasks: recognize mouse click requests, register keyboard commands, deliver visual content, connect to printers, ports, drives, etc., organize content. Electronic devices usually come with OS capabilities and they are already equipped with the correct one. Individual applications require specific OS technologies. An operating system connects all parts of your computer in order to allow each part to do what it needs to while working with the other elements in the computer. The operating system also communicates with users through the equipment and applications it handles. When you type words on the keyboard, click a link with your mouse, press function commands on the keyboard or scroll, you are giving the computer a command. Your operating system takes the information from you and puts it into place using algorithms and technology. Examples of different operating systems are Android, BSD, iOS, Linux, OS X, QNX, Microsoft Windows, Windows Phone, IBM Z/OS. Depending on your device and the applications you use, you will need one of these operating systems to carry out the tasks that you request. Here are the types of operating system. Batch operating system. The users of batch operating system do not interact with the computer directly. Each user prepares his job on an offline device like punch cards and submits it to the computer operator. To speed up processing, jobs with similar needs are batched together and run as a group. Thus, the programmers left their programs with the operator. The operator then sorts programs into batches with similar requirements. Time-sharing operating systems. Time-sharing is a technique which enables many people, located at various terminals, to use a particular computer system at the same time. Time-sharing or multitasking is a logical extension of multi-programming. Processor's time which is shared among multiple users simultaneously is termed as time-sharing. The main difference between multi-programmed batch systems and time-sharing systems is that in case of multi-programmed batch systems, objective is to maximize processor use, whereas in time-sharing systems objective is to minimize response time. Multiple jobs are executed by the CPU by switching between them, but the switches occur so frequently Thus, the user can receive an immediate response. For example, in a transaction processing, processor execute each user program in a short burst or quantum of computation. That is, if n users are present, each user can get time quantum. When the user submits the command, the response time is in few seconds at most. Operating system uses CPU scheduling and multi-programming to provide each user with a small portion of a time. Computer systems that were designed primarily as batch systems have been modified to time-sharing systems. Distributed operating system. Distributed systems use multiple central processors to serve multiple real-time application and multiple users. Data processing jobs are distributed among the processors accordingly to which one can perform each job most efficiently. The processors communicate with one another through various communication lines, such as high-speed buses or telephone lines. These are referred as loosely coupled systems or distributed systems. Processors in a distributed system may vary in size and function. These processors are referred as sites, nodes, computers, and so on. Network operating system. Network operating system runs on a server and provides server the capability to manage data, users, groups, security, applications, and other networking functions. The primary purpose of the network operating system is to allow shared file and printer access among multiple computers in a network, typically a local area network, LAN, a private network, or to other networks. Examples of network operating systems are Microsoft Windows Server 2003, Microsoft Windows Server 2008, Unix, Linux, Mac OS X, Novel NetWare, and BSD. Real-time operating system. Real-time system is defined as a data processing system in which the time interval required to process and respond to inputs is so small that it controls the environment. Real-time processing is always online, whereas online system need not be real-time. The time taken by the system to respond to an input and display of required updated information is termed as response time. So in this method, response time is very less as compared to the online processing. Real-time systems are used when there are rigid time requirements on the operation of a processor or the flow of data, and real-time systems can be used as a control device in a dedicated application. Real-time operating system has well-defined, fixed time constraints, otherwise system will fail. For example, scientific experiments, medical imaging systems, industrial control systems, weapon systems, robots, and home appliance controllers, air traffic control system, etc. There are two types of real-time operating systems. Hard real-time systems. Hard real-time systems guarantee that critical tasks complete on time. In hard real-time systems, secondary storage is limited or missing with data stored in ROM. In these systems, virtual memory is almost never found. Soft real-time systems. Soft real-time systems are less restrictive. Critical real-time task gets priority over other tasks and retains the priority until it completes. Soft real-time systems have limited utility than hard real-time systems. For example, multimedia, virtual reality, advanced scientific projects like undersea exploration and planetary rovers, etc.